Hi everyone, welcome back to our channel. Today we are going to dive into the world of Python's powerful numeric library Numpy. If you are interested in data analysis, machine learning or scientific computing, then you have come to the right place. In this video, we'll go through the basics of Numpy to help you to understand and use this fantastic library. So let's get started. What is Numpy? Numpy, short for numerical Python, is a popular open source library for performing numerical operations in Python. It provides high performance, easy to use data structure and functions, making it an essential tool for anyone working with numerical numbers and data. Some of the key features of Numpy include efficient multidimensional array object called ND array, mathematical functions for element-wise and linear algebra operations, broadcasting for easy manipulation of array with different shape, and tools for reading and writing data to and from disk. To start using Numpy, you will need to install it first. You can do it using pip, the Python package installer. Simply open up your command prompt or terminal and type pip install Numpy. But in Jupyter Notebook, you can use this pip install Numpy, and we already installed it, so we don't need to install it anymore. So when you install the Numpy, you can use it in your program. To use Numpy in your Python script or Jupyter Notebook, you need to import it first. So it's common to import Numpy with the alias np to save some typing. Here is how you do it. Import Numpy as np. Now you are ready to use Numpy. One of the most important features of Numpy is ND array, a powerful multidimensional array object. Let's see how to create some basic array object in Numpy. For example, I have a list ls from some numbers 1, 2, 3, 4. Then I want to convert this list to ND array. So I can say that ND array equal np dot array my list, and if I print the result ND array, the result is an array Numpy array with entity including 1, 2, 3, and 4. And if I ask Python to give me the type of ND array, it is Numpy ND array, and this is very important for us. And another important features of Numpy array are shapes of the array, and you can see array as a generalized of matrix, and so the shapes, for example, could be a number of row and number of columns, or even higher dimension. So for example, if I ask np.shape of the previous Numpy array, then I will get 4 and nothing. It means that it is one-dimensional array with 4 elements. But I can create two-dimensional Numpy array. For example, I have a list A, and list A is a Numpy array, sorry, an ND array, NP array of this look like a 2 by 2 matrix or 2 by 3 matrix. So the first row is 2, 3, 4, and the second row is 5, 6, and 7. And sorry, I need another. And if I ask the shape of A, another way to extract the shape of A is that A dot shape, and then open and close. Sorry, we don't need open and close parentheses. A dot shape, it gives me the shape of the array A, which is 2 by 3. It is we have two lists of the length of 3, or we could say that we have a 2 by 3 matrix. We could reshape array also from, for example, we could have a transpose of this matrix, or turning the 2 by 3 array to 3 by 2 array, or a 2 by 3 array to a column array, or vice versa. For example, I can say that a dot reshape 3 and 2, and you can see that it reshaped the array A to another array with 3 row and 2 column. But I can do it by converting the array with the matrix to a column vector. So I can say A dot reshape -1 and 1. See the result. -1 and 1 is actually says that we have one column, so convert every row here. So I don't know how many rows I need, so I put -1. And if I say A dot reshape 1 and -1, then I have a row array or row matrix, and the shape of this matrix is 1 by 6. So for example, if I call this B, then B dot shape is 1 and 6, and as you can see. In the next video, I will talk about operations on NumPy array and broadcasting. Thanks for watching.